Fanning Island. A coral atoll belonging to the group of islands in the tropical West Pacific region. This group of islands is called the Line Islands, and it is located in the sovereign country called Republic of Kiribati. These islands group is located 1,200 miles southwest of Hawaii. Remote and isolated, but they are inhabited by people originated from the Malay archipelago. The island is pristine and is yet to be exploited by others from the outside world. However, under this postcard perfect views of the ocean, and its islands, there is a shocking discovery awaits us. Why are we here? What are we looking for? Ocean Quest Global and Sea Shepherd Dive is taking part in an expedition on board the research vessel belonging to Sea Shepherd Conservation Society, the RV Martin Sheen. The goal for us is to assess and record our findings in the coral reefs at Fanning Island. Ocean Quest Global is represented by its founder, Anwar Abdullah. His exploration is assisted by the captain and crew of the Martin Sheen. Several sites is established for survey on shore as well as in the reefs. On shore, the crew members is introduced to basics of coral taxonomy. Here, the crew collected coral skeleton that still carries features for identification. The goal for this taxonomy is to find as many species of dead corals on the shore. Then, the underwater survey is conducted to find and identify the number of living species of corals adjacent to the shore sites. By comparison of the numbers of living species against the number found on shore. As there are no information from this reef prior to this expedition, this step of assessment is necessary to construct a baseline data for coral reef degradation in the Fanning Island. This information can be used as continuation in future research, as well as for use as a global comparison with other geographical areas around the world. Through this assessments, we found that only 4 species of corals survived the devastation, from the 700 previously known species that inhabits the reefs in this part of the Pacific region. The surviving number of species is less than 0.3% of what it used to have. Although there is some signs of newly recruited corals, the entire reef looks barren and dead. 2016, Sumbawa, Indonesia. The bleaching episode at this location for entire year and documented throughout its progress. The first sign of mass bleaching can be seen as early as in January in 2016. The observations made at this location also brought us new discovery. The coral bleaching at this location is impacted by the sun's radiation instead of just the rising sea surface temperature. This can be seen on the coral colonies, as the bleaching begins at the top of the colony. Temperature-induced coral bleaching is different, and it occurs uniformly throughout the coral colony. This radiation-induced bleaching is named photobleaching. The impact of photobleaching is severe that the entire reef succumbs to the catastrophe. By December 2016, this once pristine reef called Labuanage is lost. Global challenges in coral reef restoration. Techniques and methodology isn't the only factor limiting coral reef restoration. There are many factors outside coral biology that could impose major hindrance to coral conservation, especially when it is in a global scale. Demography, geography and climatic changes dictate many aspects of coral reef rehabilitation. Demographic challenges. Looking into demographic factors, many will think of the physical destructions by people such as boating, fishing and tourism. However, there are many indirect impacts influencing coral conservation that's far more than just the visual and physical. Some of the key hindrance to almost all coral conservation is governance. In fact, human stewardship of the coral reefs globally is greatly hindered by politics and poor governance. All other condescending aspects of human impact is actually secondary. Climatic challenges. Despite the awakening of awareness that seem alarming, climate change has mixed impact on coral reef globally. In Southeast Asia, most reefs impacted by El Niño recovers. In the Pacific, however, the recovery isn't as rapid as Southeast Asia. During the expedition to Fanning Island on board RV Martin Sheen, we discovered that 99% of the reef at the outer rim of the atoll is dead and with very small signs of recovery. There are some signs of new coral growth, but it is less than 0.5% as compared to the reef that is lost. The distribution is too sporadic to have rapid recovery. Post-bleaching devastation in most countries in Southeast Asia, especially in Malaysia and Thailand, is minimal. Most reef recovers within 1 year. There are also less loss of diversity as compared to the Pacific Islands. In Indonesia, some reefs are badly affected by the bleaching episode in 2016. At one location, Sumbawa, the entire reef is devastated and loss of diversity is 99%. There is some new coral recruitment at that reef in 2017, but it is very little as compared to what's lost. Thus, climate change differs in its severity and impact on global coral reefs. With good management and restoration, most reef can be saved provided it is implemented without delay. Geographical challenges. Severity of coral reef destruction differs from one location to another. Every location is different in terms of cause of damage as well as how severe their conditions are. Impact versus recovery is also different in every location. There are reefs that sustain total loss and they are the hardest to rehabilitate. This is simply because there are no corals left that can be extracted for propagation. Corals are rescued from broken fragments found on the seafloor. This means that there are still living polyps that can be saved and propagated. But, at some islands in the Pacific has none. There are no corals left to be rescued. The only hope for these locations is new larvae recruitment brought in by the oceanic currents from other locations. Importation of coral species into the devastated areas is not encouraged as there are many risks, including invasive species that could disrupt the natural balance of local environments. Locations in the Indian Ocean such as Maldives suffer similar fate as the Pacific Islands. Most of the major reef systems in this area is devastated by bleaching and tsunami. Naturally, the recovery of these reefs is very slow. In fact, globalizing coral restoration is meant to help speed up their recovery. The global strategy. Ocean Quest and its partner Sea Shepherd Dive are undertaking this global initiative through a strategy that manages the challenges while driving the campaign with new technology. Introducing broad-scaled assessment system and better ways of coral propagation is part of the steps. Ocean Quest set aside its proprietary knowledge of coral propagation to enable it to become universally available. Understanding the dynamic of the changing climate and its impact in different regions of the world is also part of the processes. By having a planting strategy, most seasonal challenges can be overcome. Demographic challenges are overcome through empowerment of the people and letting them take stewardship of their coral reefs. Ocean Quest provides training and give advice to local authorities for better governance of their coral reef resources. This action directly allows for a better management of time and resources to operate in many locations around the world. Coral restoration systems and technology. There are few coral gardening systems that is successful, while many are still in its experimental stages. Therefore, even if there is a good rehabilitation system, there are many other things that must be considered when expanding it to a global scale. There are many other factors besides the techniques and systems that can hinder coral restoration. For now we just look into the systems and technological side first. This consideration includes acquired data and materials used in the systems. Global data acquisition. First part of globalization is to acquire a standard and accurate data on conditions of reefs around the world. Despite many work have been done on acquiring coral reef data, there are no reliable global information that can be used to support a specifically worldwide coral restoration. Existing methodology of coral survey using transects cannot acquire accurate data for large-scale planning and monitoring. This is simply because their survey methodology rely on human observations, which is highly prone to error, especially when many people are involved in collecting data. It is time that newer technology is brought into coral reef survey. OceanQuest are developing a survey design using a combination of Geographical Information System, GIS, 3D and 360 imaging technology. This technology allows for much broader mapping information system that can be used for global-scale coral reef restoration. This system uses diver propulsion vehicles, DPV, which allows for surveying large areas of coral reef on a single dive. It also incorporates a fully autonomous data collecting probe that acquires scientific information for purpose of analysis. On board these vehicles, there is a 360 underwater camera that acquired images and videos without errors like the ones acquired through human observations. A side-scan sonar built into the DPV provides seafloor contour map that is useful for planning large-scale coral transplantation. Although this development is yet to be made available worldwide, it is well on its way towards reaching its goals. This technological advancement is made possible through collaboration with equipment manufacturers that come together to help bring underwater sciences, particularly coral survey, to the same level of technology as space and other technologies. Besides the machines, there are development of data applications have to be developed and refined. Just like all other technological advancement, the system shall improve over time and eventually replace the existing way on how coral reef is surveyed. By developing this technology, OceanQuest opened the doors to new dimensions, and to finally make global-scale coral reef rehabilitation possible.